The story of the Antonov An-225 Mariah begins not in a design bureau or on a drawing board, but in the vast expanse of the Cold War arms race, where the Soviet Union found itself facing an engineering problem so monumental that it would require building the largest aircraft ever to take to the skies. This is not simply a tale of aviation achievement, but a chronicle of how geopolitical competition, national pride, and the relentless pursuit of technological superiority drove an entire nation to create something that defied the very limits of what engineers believed possible. In the spring of 1974, the United States unveiled its space shuttle program to the world. The announcement sent shockwaves through the corridors of power in Moscow. The Americans had developed a reusable spacecraft that could launch like a rocket, operate in orbit, and return to Earth by landing on a conventional runway like an aircraft. For the Soviet leadership, this represented more than just a technological achievement by their rivals. It was a strategic threat, a potential military asset, and, perhaps most importantly, a propaganda victory that demonstrated American technological prowess at a time when the Cold War remained locked in its most intense phase. The Politburo understood that the Soviet Union needed an answer, and they needed it quickly. The Soviet response came in the form of the Buran program, their own reusable spacecraft initiative that would mirror and, in some ways, exceed the capabilities of the American shuttle. Development began in earnest in 1976 under the direction of NPO Molnia, with Gleb Lozino-Lozinski serving as the chief designer. The Buran orbiter itself would become a masterpiece of Soviet engineering, incorporating lessons learned from decades of space exploration and featuring fully automated flight systems that would eventually allow it to land without human intervention. But as the program progressed through the late 1970s, a critical problem emerged that threatened to undermine the entire project before a single Buran could reach orbit. The issue was transportation. The Buran orbiter measured over 36 meters in length, with a wingspan of nearly 24 meters. It weighed approximately 62 tons when empty, and would require extensive ground testing at facilities spread across the vast Soviet territory. The spacecraft needed to travel from the production facility at the Tushino machine-building plant in Moscow to the Baikonur Cosmodrome in Kazakhstan, a distance of over 2,000 kilometers across some of the most challenging terrain in the Soviet Union. The existing Antonov An-22, the largest aircraft in the Soviet inventory at the time, was wholly inadequate for this task. The An-22 could carry a maximum payload of 60 tons, leaving virtually no margin for the support equipment and fuel needed for such a long journey. The Soviet railway system, while extensive, could not accommodate the orbiter's dimensions without extensive and expensive modifications to tunnels, bridges, and overhead electrical systems along the entire route. The Soviet leadership turned to the Antonov Design Bureau in Kiev, Ukraine. This organization had earned its reputation by producing some of the most capable cargo aircraft in the world, including the An-12, An-22, and the An-124 Ruslan, which was then under development. The Bureau's chief designer, Oleg Konstantinovich Antonov, had passed away in 1984, but his successor, Pyotr Vasilyevich Balabuyev, inherited both the legacy and the seemingly impossible challenge. The directive from Moscow was clear and uncompromising: create an aircraft capable of carrying the Buran orbiter and its associated rocket components externally, transporting them safely across thousands of kilometers, and doing so on a timeline that would allow the Soviet Union to demonstrate its space shuttle before the end of the decade. The specifications were staggering. The aircraft would need to carry at least 250 tons of cargo, either internally or mounted on its fuselage. It would require sufficient power to lift this enormous weight while maintaining stable flight characteristics, despite the massive aerodynamic disruption caused by carrying a spacecraft on its back. The design would need to incorporate redundancy and reliability far beyond normal aviation standards, because a failure during transport could destroy years of work and billions of rubles invested in the Buran program. And perhaps most challenging of all, this aircraft would need to be designed, built, tested, and made operational within just a few years. The Antonov team began work on what would become the An-225 in 1985. The designation itself carried significance, with the number representing the maximum takeoff weight in tons multiplied by 1,000, giving a target of 640 tons, though this would later be exceeded. Rather than starting from a blank slate, the designers made the pragmatic decision to base their new giant on the An-124 Ruslan, which was already the world's second-largest aircraft and had proven its capabilities in extensive testing. This decision saved precious time, but created its own challenges, as the An-124 would need to be substantially modified to meet the new requirements. The engineers extended the fuselage by nearly 13 meters, bringing the total length to 84 meters. They added 2 additional turbofan engines to the existing 4, creating a 6-engine configuration that generated a combined thrust of over 230,000 kilograms. Each engine was a Progress D-18T, the most powerful turbofan engine produced in the Soviet Union, capable of producing over 23,000 kilograms of thrust. The wing structure was reinforced and slightly extended to a span of 88.4 meters, creating a wing area of over 905 square meters. The tail section underwent perhaps the most visible modification, with the single vertical stabilizer of the An-124 replaced by twin stabilizers positioned at the ends of the horizontal stabilizer. This configuration was essential to provide clearance for the Buran orbiter when mounted on the fuselage and to maintain directional stability despite the massive disruption to airflow caused by the external cargo. The landing gear system represented an engineering achievement in its own right. The An-225 required 32 wheels arranged in 7 sets of 4-wheel bogies, plus the nose gear. This distribution was necessary not just to support the aircraft's weight, but to ensure that it could operate from the same runways used by the An-124, without exceeding pavement loading limits. The main landing gear could be hydraulically steered to reduce turning radius and minimize tire wear during ground operations. Each tire was specifically manufactured to withstand the enormous loads, with the entire landing gear system capable of supporting weights exceeding 600 tons. The construction of the first An-225 took place at the Antonov serial production plant in Kiev, where workers labored around the clock to meet the demanding schedule. The facility had to be modified to accommodate the giant aircraft, with new assembly jigs constructed and the main assembly hall expanded. Specialized lifting equipment capable of handling sections weighing dozens of tons had to be designed and built. The logistics of simply moving components within the factory became a significant undertaking. The Soviet aviation industry mobilized resources from across the nation, with component manufacturers from dozens of cities contributing specialized systems and equipment. On December 21, 1988, the An-225 lifted off from Kiev's Sviatoshin airfield on its maiden flight. Test pilot Oleksandr Galunenko commanded the aircraft, with a full crew monitoring every system during the 34-minute flight. The takeoff roll consumed over 3,000 meters of runway, and the aircraft climbed ponderously into the winter sky, its 6 engines generating a sound that witnesses described as a continuous rolling thunder. The initial flight envelope was conservative, with the aircraft reaching an altitude of only about 4,000 meters and maintaining relatively low speeds. But the flight was successful, demonstrating that the basic design was sound and that the modifications to the An-124 airframe had not introduced any critical flaws. The test program continued through the winter and into the spring of 1989. Each flight expanded the envelope slightly, testing different configurations, weights, and flight conditions. Engineers discovered and corrected minor issues with hydraulic systems, flight control responses, and engine coordination. In May 1989, the An-225 carried the Buran orbiter on its back for the first time. The spacecraft was mounted on a specially designed cradle attached to the fuselage, positioned carefully to minimize aerodynamic interference while maintaining the aircraft's center of gravity within acceptable limits. The combined vehicle weighed over 400 tons at takeoff, and the sight of the massive aircraft carrying an even larger spacecraft created an image that seemed to defy physics itself. The An-225 performed its mission flawlessly, transporting Buran orbiters and Energia rocket components between production facilities, test sites, and Baikonur Cosmodrome. On June 13, 1989, the aircraft made its international debut at the Paris Air Show at Le Bourget, where it stunned Western observers who had been unaware of its existence until shortly before the event. Aviation experts from around the world examined the giant aircraft, many expressing disbelief at its size and capabilities. The An-225 performed a flying display that demonstrated its surprising agility for such a large aircraft, banking and maneuvering in ways that seemed impossible for something weighing hundreds of tons. But even as the An-225 was proving its worth, the political and economic foundations of the Soviet Union were crumbling. The Buran program, despite its technical success, was consuming enormous resources at a time when the Soviet economy was collapsing under the weight of decades of inefficiency, military overspending, and failed central planning. The first and only orbital flight of the Buran took place on November 15, 1988. A fully automated mission that completed 2 orbits before landing perfectly at Baikonur. It was a triumph of Soviet engineering, but it would also be the program's swan song. The dissolution of the Soviet Union in December 1991 effectively ended the Buran program. The newly independent Russian Federation, struggling with economic chaos and political instability, could not justify the billions of rubles required to continue development. The Buran orbiters were placed in storage, and the An-225 suddenly found itself without its primary mission. The aircraft had been designed for a specific purpose, and with that purpose eliminated, its future became uncertain. A second An-225 had been under construction when the Soviet Union collapsed, with the airframe approximately 70% complete. Work stopped abruptly in 1991, and the incomplete aircraft remained in the assembly hall in Kiev, a monument to ambitions that would never be realized. The first An-225, now under the ownership of Antonov Airlines, a commercial subsidiary of the Antonov Design Bureau, was placed in storage in 1994. For 7 years, the largest aircraft ever built sat unused in a hangar, its 6 engines silent, its massive cargo hold empty. The revival of the An-225 came not from government contracts or space programs, but from the commercial cargo market. In the late 1990s, the global economy was becoming increasingly interconnected, and companies were discovering a need to transport oversized and extremely heavy cargo items that could not be accommodated by conventional aircraft. Power generation equipment, industrial machinery, humanitarian aid supplies, and military equipment all required transport capabilities that exceeded what was readily available. Antonov Airlines recognized an opportunity and began negotiations to return the An-225 to service. The restoration and modernization program began in 2000 and required significant investment. The aircraft had been in storage for years, and many systems needed to be overhauled or replaced. Modern avionics were installed, including GPS navigation, updated communications equipment, and digital flight management systems. The engines were inspected and rebuilt. The structural integrity of the airframe was thoroughly examined and certified. On May 7, 2001, the AN-225 flew again, beginning a new career as a commercial cargo hauler. The aircraft proved to be remarkably successful in its new role. It could carry single pieces of cargo weighing up to 189 tons internally, and even heavier loads when carried externally. The cargo hold measured over 43 meters in length, 6.4 meters in width, and 4.4 meters in height, providing over 1,300 cubic meters of space. The nose of the aircraft could be opened upward, allowing cargo to be loaded and unloaded from the front, using ramps and specialized equipment. The AN-225 could operate from any airport with a runway at least 3,500 meters long and sufficient pavement strength, giving it access to hundreds of airports worldwide. Over the following 2 decades, the AN-225 transported some of the most challenging cargo in the world. It carried locomotives, generators weighing over 100 tons, wind turbine blades over 40 meters long, and entire factories disassembled for relocation. It delivered humanitarian aid to disaster zones, transported military equipment for NATO operations, and carried spacecraft components for various space agencies. Each mission generated revenue that helped sustain both the aircraft and the Antonov Design Bureau, which continued to operate in independent Ukraine. The aircraft became a celebrity in aviation circles, drawing crowds wherever it landed. Enthusiasts would track its flights online and gather at airports to photograph and film the giant as it arrived or departed. The sight of the AN-225 taking off, its 6 engines glowing in the evening light, its massive wings flexing under the load, remained one of the most impressive spectacles in modern aviation. It represented not just engineering achievement, but the persistence of human ambition and the ability to find new purposes for technologies developed for entirely different reasons. The technical specifications of the AN-225 remained impressive decades after its first flight. Its maximum takeoff weight reached 640 tons, with a maximum payload of 250 tons. It could fly up to 15,400 kilometers when carrying a 200-ton payload, or over 4,000 kilometers with maximum payload. Its cruising speed reached 850 kilometers per hour at an altitude of up to 12,000 meters. These capabilities remained unmatched by any other aircraft, and despite numerous proposals for larger cargo aircraft from various manufacturers around the world, none were ever built. The story of the AN-225 illustrates several important themes in Cold War history and the development of aviation technology. First, it demonstrates how military and political competition drove technological innovation to extraordinary levels. The aircraft existed only because the Soviet Union felt compelled to match American achievements in space, regardless of cost or practicality. The decision to build the AN-225 was not made based on commercial viability or civilian need, but purely to support a space program that was itself driven by Cold War competition. Second, it shows how technologies developed for specific purposes can find unexpected applications when circumstances change. The AN-225 was obsolete for its original mission almost as soon as it became operational. Yet it found a successful second life in commercial service that its designers never anticipated. This adaptability reflects both the inherent capabilities of the design and the creativity of those who sought ways to keep it flying. Third, the aircraft represents the technical capabilities of the Soviet aviation industry at its peak. Despite the economic problems and political dysfunction that would ultimately destroy the Soviet Union, the nation's engineers and workers could still produce machines that exceeded anything available in the West. The An-225 was not a copy or an adaptation of Western technology, but an original design that solved problems in ways that reflected distinctly Soviet approaches to engineering, emphasizing robustness, payload capacity, and operational flexibility over comfort or efficiency. The ultimate fate of the An-225 adds a tragic coda to its story. On February the 24th, 2022, Russian forces invaded Ukraine, beginning a conflict that would devastate much of the country. The An-225 was at its home base at Hostomel Airport near Kiev when fighting broke out. Despite attempts to evacuate the aircraft, it was caught on the ground when Russian forces attacked the airport. The subsequent battle destroyed the hangar where the aircraft was housed, and the An-225 was damaged beyond immediate repair. Images of the destroyed aircraft circulated worldwide, generating an outpouring of grief from aviation enthusiasts and Ukrainians who saw the aircraft as a symbol of their nation's technical achievements and independence. Antonov has announced intentions to rebuild the An-225 using the partially completed second airframe and components salvaged from the destroyed aircraft. But the timeline and funding for such a project remain uncertain. The cost would likely exceed several $billion, and the commercial justification for rebuilding the aircraft is questionable, given the availability of the smaller but still capable An-124 fleet. Yet, the symbolic importance of the An-225 to Ukraine may ultimately prove more important than purely economic considerations. The legacy of the An-225 extends beyond its physical existence. It demonstrated that the limits of what is possible in aviation are defined not by physics alone, but by imagination, determination, and the willingness to commit resources to ambitious goals. It showed that Cold War competition, despite its dangers and costs, could drive innovation that produced lasting benefits. And it serves as a reminder that the great technological achievements of one era can find new relevance in another, if those who inherit them have the vision to recognize their potential and the skill to adapt them to new purposes. The An-225 was built to carry a Soviet spacecraft that flew only once, but it ended its days carrying the commerce of a globalized world, a fitting symbol of how profoundly the world changed in the decades after the Cold War ended.